Kidding. Um, Thank you for inviting me to serve on this panel. I feel a little intimidated knowing who else is on here and the topic. And so I am not a remote sensing expert by any means. I am a user. And some of the things that I wanted to just mention as part of the challenges as we transition from MODIS to VIIRS and bring on new satellite products is just as an emissions modeler looking at long-term records, trying to look at, changes and variability over time. We see these big step functions in our emission estimates as soon as we add on or take away one of the driving satellite products that we use. And we see this not only with our fire detections, but also with our land cover data sets that are also derived from different satellite products. So I guess one of the challenges that I would love this community to think about addressing is how do we smooth out or have consistent long-term records when we're dealing with the application of different satellite products that lead to very different results. And some of the earlier talks showed, we run FIN with just MODIS, and we have a consistent data set back to 2002 when both MODIS instruments were up. And then we've also made a version where we include VIIRS as well as the MODIS detections. And there's a huge difference between those two estimates. And we recognize it's there, but how do you handle it? How do you justify it? Is there some way to help smooth out as you go through time using these different products? So that's all the biggest point that I wanted to make in this panel, and I'll listen and learn and chime in as the conversation goes on.
Thank you, Christine. We'll move on to Ed Hyer. Ed, do you want to share your screen? I know you have a few slides.
Sure. If you want me to share, I can do that. How's that? People see that?
Yeah, we can.
Yes, online, yes.
Okay. Yeah. Is that showing up? Am I being seen and heard? Let's see what's here. Yeah, this won't take long at all because a lot of the stuff you've already seen, but the issue of using multiple sensors, which is something you really want to do because the different sensors have complementary capabilities. And so if you want to use multiple sensors, you have to figure out how to normalize across them. And so these are just some examples of just some basic things that you need to understand in order to normalize between multiple sensors. And this is true whether you're using 2 MODIS sensors, or whether you're trying to use 3 VIIRS sensors, or whether you're trying to actually integrate a whole large constellation of fire detection capable satellites. So the pixel size is going to drive the detection limitation, because the contribution to the fire versus the contribution of the non-fire parts of the pixels is determinative in terms of threshold. These are fundamentally contrast-based measurement techniques. So the other thing is, the atmospheric path. The MODIS instrument provided us with 2 decades of really nice, very clean data, because the position of the 3.9 micron MODIS band was one of the cleanest parts of the whole spectrum. But other sensors have other desirable capabilities and more atmospheric attenuation. So we're going to see more atmospheric path effects. So just to say, okay, what does that mean in terms of quantifiable metrics of fire activity? Well, the metric here is sort of a hybrid metric between satellite and a ground-based estimation. So this is fire radiative power per clear sky land area sensed. And the point is that when you plot this curve, what you see really clearly is, first of all, the difference between MODIS and VIIRS. So the red, orange, yellow, and the brown curves are VIIRS, and the blue curves are MODIS. And then you see very clearly the difference between daytime detection and nighttime detection. This is all just Southern Africa. So this is a single fire regime sort of measured at daytime and at nighttime. And then you see in the different curves in each color grouping, the effects of increasing the angle and the path length. But the integral under this curve, the way this is expressed here, so fire radiative power on the X and the density per area sensed, the integral under this curve is the total estimated fire activity, the total time integrated estimated fire activity from a sensor of these approximate capabilities. And you can see that MODIS does not equal MODIS. You know, there's a lot of variation depending on what part of the MODIS scan you're looking at. And MODIS and VIIRS have these big differences. But it is possible to quantify those differences. It is possible to correct them. And we did a little study on this. And the punchline was that, and Junwang showed a very similar correction result. So without correction, the variation in FRP density from one position on the scan to another is 95% determined by the scan position. And we can reduce that very sharply by applying corrections for the relative sensitivity at different geometries and applying a correction for the atmospheric transmission components. This is the aqua corrections on the top and the VIIRS corrections on the bottom. And the point that I want to make here is that the order of the curves is different, because in the MODIS sensor here at the top, the transmittance correction is relatively small, and the sensitivity correction for pixel size variation is relatively large. For VIIRS down here on the bottom, the sensitivity correction for pixel size in the orange is relatively small. The transmittance correction is relatively large. But by applying these corrections, not only can we eliminate this strong artifactual signal of dependency on scan position in FRP density, but we can also prove this out by simulating a MODIS-like FRP derived from VIIRS data or VIIRS-like FRP derived from MODIS data. And we see that by using these corrections, we can actually get similar answers. And that makes us optimistic that this is a method we can use to build a multi-sensor integrative constellation. So that's what I wanted to bring, was just some considerations about how do we build constellation-based approaches, and what do we have to do to normalize multiple sensors to use them for emissions estimation. So yeah, I'll pass it to someone else.
Thanks, Ed. Fantastic. So I'm glad to see that you've already done some of this analysis. We will move next to Arlindo. Arlindo, can you share your screen?
Yeah, can you hear me? I'll share here briefly. Actually, desktop one.
Yeah, we can hear you.
Okay, can someone over there, I uploaded to the Google Drive. I do not use Zoom here, so it does not really want it to share my screen. So if someone could, should be the Silva Rev1 on the Google Drive. I uploaded before.
There's two.
Yeah, the one that says Rev1 is the second one, so it should be there. So while the presentation, I'm just going to say a few words about, VIIRS and into going to VIIRS, the things that, as we're looking to QFED, we are looking into take advantage of. I think it's, I think June did a great job describing some of the new features in Fielder, specifically Fielder 2 during the nighttime. which is one of those things we, pretty much would like to take advantage of. One is the atmospheric correction, right, which is very important for combining SUMI NPP and OR20, and a lot of that sort of intrasensor sort of bias can be traced back to actually like atmospheric correction. Little things like I think June also alluded to it, was related to the bow tie correction. And those corrections, they all in field and 2. Oh, great. If you go to slide number 2, please. And 1 second here. Great. So if you can put in display settings and on the top, yeah, and get out of presentation mode. Perfect. Right. So I set 2 set of issues here to be dealt with. One is what I call the housekeeping issues, right? A proper atmospheric correction. I have a couple of slides. In terms of time, I think June already covered that when he discussed some field. Another one is the pesky bow ties. And those are largely addressing field 2, which is, the primary data set right now is at night, because there's, reliance on the day-night band for the VF, as it described. But again, we are looking now in extending a lot of that detection in that sort of methodology also during the day. So you can have field during the night and the day, although the VF, because of the reflect radiation during the day, may not work as well. So another set of issues is the ability to retrieve FRP, and the importance of actually to using multispectral data. I think June talked about the active fire detection, right? Using different wavelengths to improve your fire detection. But also one might be able to use multispectral to retrieve MCE even during the day. If you skip 2 slides and you go to slide number, yeah, I'm not going to talk about bow tie correction stuff because I think June already covered that. So the next one, that's right. So the way we've been approaching this problem, there's a number of reasons for doing this, is we like to generalize, the well-known old Dozier bispectral algorithm, right? Where you was assume a uniform fire temperature, and you use 2 channels, typically 4 micron and 11 micron, to solve for this uniform, kinetic fire temperature. And it's been well known for a long time. That doesn't quite work for fires. They are non-uniform, where you do have smoldering and flaming. So we did sort of look in here a model that's has been around for some time, which is you consider now a flaming and smoldering portion, right? And right now, and then you have both the fraction of the smoldering and the fraction of the flaming, and you have now not 2 parameters in the bispectral model, but you have 4, right? And it's called it biphasic because it does explicitly account for the 2 phases of the fire. Not going to go into detail. You can actually formulate that using Markov chain Monte Carlo, algorithm with proper priors for smoldering and inflamed fires. And you can actually solve for each fire you can get the posterior, actually the full uncertainty for things like your total FRP. You can decompose your FRP in flaming and smoldering components, right? And you can do also the flaming, fraction. And very importantly, you can get also the flaming heat flux, right? Which is the amount of energy from the heat flux by the size of the heat flux. And that is primarily what you need to drive polymerized models such as, the Freitas, model, right? So it's not really the FRP that matters so much, but just the flaming, because this molding, portion most likely would be have a smaller heat flux that stays, in the boundary layer. So we just sort of here's some results of some simulation on the right compared to the standard FRP retrieval. And that's the Aussie case, the same one I think that we are used to derive. And you can see, the standard FRP algorithm has a large bias for large fires, right? I think that's well known. And by simply solving this problem in a biphasic way, you kind of nailed it. Actually it seems to work, quite well, right? And so the other upshot of that is that you are able also to derive from this modified combustion efficiency, right? Because you can simply have your flaming ratio, right? Flaming to total energy ratio as another indication of modified combustion efficiency, and you can show that is related to the VF at night that June discussed earlier. So next, if you show the next slide, I'm not going to talk much about the whole the wavelength thing, but again, you don't need to rely only on the day-night band. Actually, you can do a quite decent job even at night by using the 2-micron channel. And this algorithm should be generalizable during the day, although there's always reflect radiation, is going to be noisier, but it's not really it's very likely that that would be produce some MC estimates and also heat fluxes during the day. So we're trying to look at the different sensors for which we can generalize that for. Certainly you can do that VIIRS, hopefully day and night. At night, we cannot use the day-night band, probably not during the day. There's a little problem with MODIS at night, right? Because the 2-micron channel at MODIS is not reported at night. It's not even at level 0. It's not available at all. So we may have a little bit of problem. However, the GO series and Sliter and all of those seem to have the channels that we require. So we ought to be able. So we are now in the process. Filter 2 have a computer for 2019. And at night, we are actually using the biphasic algorithm to compute all of those parameters at night and drive polymerized models and document the whole behavior, comparing it with the VF as well. So in a nutshell, I think we ought to be able to have MC estimates also extended during the day, even with a little noisier, but I don't think we really, not having it in night bed during the day may not be stopping, something would stop us from doing it. So that's just my thoughts. I could, if we had a discussion later on, I can talk about combining multi-sensors, things that Ed was alluding to, but I'll stop here for interest of time.
Thanks, Arlindo. We have one last panelist, Mark Parrington. Mark.
Hello, yeah, can you hear me okay?
Yes.
Okay, let me share my screen. Just 2 slides and they should be quite quick. So thanks to Shoba and to Medina and Evelyn, the working group leads, for putting together this panel and for asking me to take part in it. So I'm going again from very much from what Christine said, from a user perspective rather than the actual sort of technical details that Ed and Arlindo covered in there. So, and I just want to sort of give an overview of what we're doing in CAMS with GFAS to make this transition from MODIS to VIIRS. And so if you can see my slide.
Yes.
Yeah, you can. Okay, great. So yeah, so this is a list of how we're proceeding in CAMS with the GFAS developments. And we have a bit of a strange setup. So I think we're in one thing that we would like to get out of this workshop and in this discussion is, I mean, are we doing the right thing and are we going along the right lines? Because we're doing something slightly different to what is being sort of promoted, or at least there's some slides that Shoba had. I don't know if we saw them with the questions that we would have on this. So where our sort of aim as an operational service has been to sort of make this transition easy by making VIIRS sort of MODIS-like, so we don't have any major shocks to the systems that could then to our system that could degrade the forecast performance. So ultimately, it's the air quality forecast skill is what we're mostly driven by. But of course, GFAS is a standalone product, and it should be it should also be consistent with what the other fire emissions data sets are showing. So we're using this 750 meter near real-time product. come to a point on that shortly. And also, sorry. Go ahead. Yeah. Okay. And also we're using these VNP CRS, so these course product files, and we're using that for the geolocation. And originally, and this is in line with what we do for MODIS, we use these course resolution product files. I don't think anybody outside of NASA near real-time production and eCMW are using these files. But it was set up because those are a lot smaller than the mod MYD03 files, which we used previously for geolocation. But this maybe isn't an issue anymore. We don't maybe need to be so concerned about the disk space, archive space so much. And also there's a sustainability question. Like I said, we're the only ones probably accessing these data, and also the 750-meter products. There was a period towards the end of last year where the production stopped and nobody knew. And I think also Luis Giglio and others had sort of issues with this. So it was restarted again, but it was stopped without any notification to us. So yeah, so we're looking at how we make this most sustainable. And I guess once MODIS is gone, then we make the effort to really make it a VIIRS sort of led product, certainly from the LEO perspective. And also we have some, I don't think we need to discuss these here, but just to say there are a number of different versions of these products from NOAA, NASA, and we've been sort of advised on using this enterprise product, but it seems to be different from some of the other versions. And so there's not a lot of clarity on exactly which data sets for VIIRS we should be accessing and using in GFAS. So I don't know if this is common to other fire emissions providers, but I think it's a point that's worth making, because from a user perspective, more generally, I think there's a bit of confusion. And then just quickly to show what this looks like, I'll skip ahead. So we have an experimental GFAS suite running now, which has both MODIS plus Suomi MPP VIIRS, and we're also developing this to add in NOAA 20, NOAA 21, because of course the worst thing that could happen would be MODIS is decommissioned and then Suomi MPP has problems because it's also well beyond its sort of anticipated lifetime. And so this, I won't go through the text, but just to show two examples. So looking at how adding in VIIRS impacts on GFAS. So we have two main GFAS versions. So we have the traditional daily output, the GFAS 1.2, and that was used for a lot of years, and it's used in all our communications activities. It's used in our current reanalysis. But in our operational forecast, we're using this hourly suite, which does hourly calculations, and then we use 24-hour averages of those with a diurnal profile that's prescribed. And so the lines here showing the black ones are this GFAS 1.2. The red dash line is our other operational GFAS that I just described. And then the red solid line is when we add VIIRS to that. And so we're adding calibration and scaling and bias correction to VIIRS to make it look MODIS-like. So we have some continuity and try and avoid any step changes in the emissions when we do, in anticipating that the MODIS will be switched off at some point. So this is one example of globally and one for the Arctic. Just to point out, our hourly GFAS has some issues that we're biased very low at high northern latitudes for some reason. This doesn't seem to be the case in the tropics or anywhere else. But we can see, at least in this case, for the Arctic Circle for 2024 through June, that VIIRS was increasing the emissions that we were getting for that region. So yeah, that's all I'm going to say. Hopefully some of these points are useful, and I think this tied with what Ed and Arlindo showed on the more technical side, I think is all valid points for discussion. And I think yeah, it would be good to have some outcome or some recommendations from this workshop along these lines.
Maybe we will just spend 10 minutes. Cindy, would you mind bringing up the slides that I made? Just have one slide, just so we can use that as a background for the discussion. While Cindy is doing that, any,
I don't know where they are.
oh, they should be in the same folder.
It shows muted. Somebody else is.
Are you looking for Shoba's slides? I have them here on my, shall I share again?
Which one?
This transition.
This one?
Just go to the last slide.
Okay.
Yeah, okay, thank you. Yeah, before I start addressing the questions I pose on this slide, any comments, questions for panelists? Either in the room here or online?
I just have a quick question, Shiva.
Hearing none, no questions. Okay.
Shiva, can
So one of the challenges, I think like every panelist brought this out, is like while we are ending MODIS era and then moving into VIIRS, there are some challenges because these instruments are not the same. That's one challenge that you've heard, like, you know, the VIIRS samples, like especially on the scan edges compared to the MODIS. And then the other thing is that we are going to miss that mid-morning orbit that Terra provided us observations in the morning. So we have 3 VIIRS instruments from NOAA and all 3 are in the afternoon orbit. So losing that morning orbit is critical because, like as Christine highlighted and Ed highlighted, like, you know, if we want to transition from MODIS to VIIRS, then there will be those biases that we need to figure out how to fix. And I'm pleased to see that looks like Ed already has started working on how to cross calibrate using 7 years of overlap between MODIS and VIIRS. But we do have UMETSAT, METEOSAT second generation MET image that will be in mid-morning orbit, but the instrument will not be of the same caliber as VIIRS, but when it launches, we will see how it looks like. But I highlighted some of well, I have to get closer to see my own font here, small font. Do we actually characterize the differences between the VIIRS and MODIS as a function of biome type, day versus night? There are some differences you've seen in some of the presentations. Function of latitude, especially VIIRS doesn't have that orbital gap that MODIS had in the low latitudes. MODIS had gaps in orbits. So MODIS was missing some fires that VIIRS actually doesn't miss. It sees all those fires in between the orbital gaps. We don't yet fully understand the omission errors and commission errors between these 2 satellites. Function of the view geometry, which we already talked about, like the MODIS pixel grows, VIIRS doesn't grow. So that's one thing that we have to understand. So anyway, these are some of the overarching questions. Cindy, I think like the guidance, or at least thinking from you all in the steering committee, is that, like, you know, some of these discussions should lead to a journal article. So I am thinking if the panelists can all, like, you know, take a lead and then, like, you know, address some of these issues and then, like, you know, put out a community perspective on how we should transition from MODIS to VIIRS. And I think that is something that we should follow up in an email. I know we are running short on time here to actually discuss this openly, but if all the panelists can say yay or nay on how you feel about it, or you can actually shoot me an email, we can follow up with the discussion. So I think like this is something that will be very valuable, and it looks like, you know, this work is already started. So I think we're in a good place for this conversation.
Yeah.
So Shoba,
I'm
sorry.
Tomorrow, in the second half of tomorrow, if the panelists come back and others who work on this sort of thing come back, we'll have, like, we have that whole time for discussion. There's also the jam board, the emissions jam board. People could put thoughts and ideas and stuff there too. But I think because we still have the poster session over the course of lunch, and we want to take a quick group photo, we don't have a ton of time right now. Any really pressing questions or?
Yeah, I just want to say just something very briefly, right? So,
Yeah.
I'm
yeah, so,
falling asleep already.
um,
So, and I think that that's a
I'll
great
share.
idea
If people online could, oh yeah, Johannes has a hand raised.
Yeah, sorry, I'm going,
Yeah, go ahead.
have I got a minute? Yeah.
We don't hear you.
You still don't hear me? I'm unmuted? Okay. Do you hear me in Kuala Lumpur there?
Now we hear you.
No.
Now we hear you.
Okay. Since I'm going to leave because I haven't slept for 24 hours after this session, I want to reinforce what Mark said about really using the non-fire detections. So detection opportunity without FRP detection is at the core of GFAS. That's why we need the geolocation for all the pixels in the level 2 products. And if the 375 meter product is now the operational product and the thing to go to in the future, we should make sure that somehow this information becomes available. And we are in discussions with EUMETSAT concerning the Sentinel-3 products, the FRP products. And it doesn't have to be super accurate, but I think it would really make sense to sit together and find a solution that applies to EUMETSAT as well as NOAA. And then with a good data compression, and it can be lossy, and in order to solve this problem once and for all. So I think that should be a recommendation coming out of here, and we should form a group to talk about that with the relevant people in the level 2 data production systems.
Makes sense. Can I? Hello, who's next? Who is the MC?
Go ahead, Arlindo.
Yeah, I don't know. It's, I think it makes, a lot of sense. It's almost like what makes me, thinking here, we have an ICAP for people doing aerosol data simulation and forecasting. And we actually meet every year, we tend to do that in person. And that really is something we could benefit for this kind of work. As I said, Johannes, there's a lot of stuff there that it needs to be, coordinated, and would save a lot of people a lot of time. But Shoba, in what you just, propose in terms of doing, I think that's a very worthwhile study, but that it really someone needs to champion that, right? I think I can speak for at NASA would be more than willing to contribute a mission, to contribute, experiments for the same time. But someone needs to step forward and really be the main point of contact for organizing such an experiment, right? So I don't know if there's anybody in this group that can, they're very spiritual like Aerocom, and someone needs to be a champion for those guys. But I think there's a lot to be learned by, doing that jointly and learning the problems that we might have, you may not have, and so on and so forth. But we need a volunteer. We need a champion for that.